7. 7. That's a positive 7. That was a positive 7. That was a positive 7, and I'm glad I looked at this. 7 for z, so I plugged in 7. So you have all three variables, -1, -5, and -7. So I'm not going to repeat it, but go back and look at it as you need to. So we're going to look at page 163, example 2a and b for infinite and no solutions. All right, so here we are back at page 163. We're looking at example 2, which is a no solution and an infinite solution. Okay, so what happens here? This is the system of equations. You have these three. So eliminate x in the second two equations. So the choice here, you got 5, 4, and 6. You got 5, -4, and 6. You have 4, -10, and 15. You got 5, 8, and 12. So the simplest thing to solve for here is to get rid of the x's. So in the second two equations, so in these two equations, right? That equation is there. That equation is there. So how are you gonna get rid of a -4 and a 6? Multiply the 4 by 3, multiply by 3, and multiply that by 2. So you get these two new equations. So when you get these two new equations and you get 0 equals 0, right? It's this cancels and this cancels and this cancels and this cancels, and you have 0 equals 0. Right, that means these two are the same plane, so they're laying on top of each other. You still have to check the third plane. Which is here. So you still have to check those equations back up to this, 5x plus 4y minus 5z. All right, that's the first equation, and -4x, that's this equation. So looking to cancel the same variable, cancel the x's for these two equations. And again, this equation and equation 3, they are the same right here. They came out to 0 equals 0. So canceling, multiply by 4, multiply by 5. So you get two new equations. The 20x and the -20x, they cancel. So you got -34y minus 60z equals -120. Now you have nothing else to do with this because the other new equation is 0 equals 0. So basically, these two equations are the same, so they're two pieces of paper laying on top of each other. If this third one, or this equation 1, if equation 1 simplifies to a linear equation here, then it intersects the ones you canceled it with. So it intersects with equation 2, which is here, and again, equation 2 and equation 3 are the same thing. So you're going to have basically two planes on top of each other, and then another plane crossing it, so it has a solution. And that solution is a line, so kind of back here, that solution is like this line, except two of these planes are the same and the other one crosses it. I don't really know how to take that apart or anything like that, or if I can take it apart. Let's see if I can do that on here, if this works. Yay. All right. All right, again, so you know, this is not live, so you can rewind, you can rewatch. All right, so back up to this. This is what we just worked on, and the planes intersect in a line, so they're an infinite number of solutions. So this is what an infinite number of solutions type of thing will look like. One of the homework problems is an infinite number of solutions. And then example B is going to be a no solution. So do the start the same way. They choose the negative 6a and the negative 2a equations. So they choose these two equations to cancel, eliminate a in the first two. So they're going to look to eliminate a out of all three of these. All right, because as you look through, that's kind of the easiest thing to do. Multiply this equation by 3, and what ends up happening, that cancels, that cancels, that cancels, that cancels, so you get 0 equals 0. It starts off as the same thing as the last equation, the last one. So you still have to go back and check. We used equation 1 and equation 2. Now you have to use equation 3 with one of these, and so I would, and they do, use equation 2 and 3, because all you have to do is multiply that by a 5. So multiply that by a 5, and you get negative 10a and 10a, they cancel. 15b and 15b, they cancel. 20 and 20, they cancel. But this does not cancel, so 0 equals 5. Whenever you get something like this, that always means no solution, because they do not equal each other. Right? This is an infinite solution, but in 3 equations you have to do it over again. You can take a closer look at that, or watch that again, listen to it again. Obviously, I keep saying that stuff. So there's only 4 problems, and I will tell you that if you watch the video, you have this advantage. One of number 9 has the worked out solution on the website of the online textbook, and then that has a solution and it's worked out. Out of those 3, one of them has a solution of x, y, z, one of them is no solution, and one of them is infinite solutions. Okay, hopefully you get those right.